University of Georgia that formed Cogent Education. And the reason that we formed the company because we had a big problem in college, and that was that our students couldn't think. They could take a test like a champion, but they couldn't apply critical thinking to find and solve problems. So we set out to try and create a solution for high schools that would align to the new requirements of the next generation science standards that would actually ask schools to make students think like scientists. Now, in working with teachers, what teachers told us was that their students really liked doing case studies, but these case studies were paper-based. So our solution was to take that kind of approach and use modern 3D gaming video technologies to engage a digital learner and take a piece of science curriculum and then immerse them in a molecular world where they can practice and hone critical thinking. So here's an example of a problem that we set 9th grade students. This is Clark, he's a calf, and he's having a seizure, and that's the problem. So the first step in solving a problem is you must understand the rules of the system where the problem exists. So there's an interactive guide where they can learn the rules of osmosis in this case. Once you understand the system, then you've got to get some data. So what we'll do is we'll fly into the brain of the calf, and then this is where we immerse the students in this 3D video game world. And in this world, they can interact with things like blood vessels and nerves and collect the data they need from the system to try and understand what's happening with the problem, with the seizures. Once you understand the system and you have some data, then you have to analyze that data so you know what that data means. And with that process, you're then able to form a hypothesis as to why that calf is having a seizure and what are you going to do about it. Once you've done that, the next step is to test your hypothesis. So the student gets to go back into the brain, pick a treatment of their choice, and then they apply it. And then all the data changes in the same order that it would do in the body, and if they pick the right treatment, they save the calf. And if they don't, then not so much. But that's okay, because we'll stop you just before you kill the calf, ask you to go and reconsider your hypothesis and try again. Because one of the most important things to learn in life about science is that scientists are wrong most of the time, and it's okay to be wrong. It's what you do with the failures. You'll learn a lot more from failure than you do from success. And then the last step is to communicate your findings. Tell me what you did and why you did it. Teachers asked us to give them data on what the students were doing during these experiences. So we developed a real-time data system whereby all the responses of the students to the questions that we're asking them within the exercise are sent to the teachers in real time, and then our system heat maps it for the teacher so that they can see which individual student needs help, where and when, so that they can intervene and modify their instruction. Fortunately, the system works in the real world. We've done a 3-year study with 1,500 kids. The blue bars represent what happens traditionally. The red bars are what happens with just 3 hours of our case studies. We saw huge improvements in just not their knowledge base of science, but their ability to apply critical thinking to problems. And unsurprisingly, the students' attitudes towards science and science careers also improved. How did we get here? Well, we started in 2008 at the UGA with an academic grant. We formed a company and got funded in 2011. And now our R&D expenses are now funded through the end of June 2016. That validation from the Fed funding led to a lot of teachers being involved in the project. And the way that we develop software is we go to teachers and we ask them one simple question, and that is, tell us where it hurts. Tell us which parts of your curriculum your students struggle with, and we'll make a case that addresses that pain point for you. That has now become a formal Cogent educator community. These are expert teachers that test the software, make sure it works in the real world, and are advocates within their peer community. The first product will be a suite of cases for biology launched at the National Science Teachers Association in March. And the software is platform agnostic. You can use it on any hardware, and there are no plugins or updates required. It's an annual subscription-based model. And we're going to start with high school biology, chemistry, etc. And we've just been funded by the Feds to start to apply this thinking to elementary school products, because it's never too early to start to think. You can buy it either directly through us, and we're in the final stages of finalizing an agreement with Ward Science as a distributor. While we're here, we're about to raise, or we're about to go and ask for our first raise of private capital investment, and we're also looking for other distribution partners. And with that, I'll take any questions.
Who's going first?
Sure. Wow, that was really exciting.
And one thing that I really liked about it was your approach to having teachers at the center of the development process from the beginning. I guess one question that I would have is, have you thought about applications in higher education as well?
Yeah.
Or professional?
Yes. Our software can be adapted to any learning environment. Doesn't matter what grade or kind of course or topic you're teaching. It's about thinking. It's about critical thinking. So these cases are also used at the graduate level as well.
So I have to say you did a beautiful job as an academic of presenting this in a very clear, businessy way that's very appealing. The case concept is appealing, and the presentation was really well done.
Thanks.
I think, you know, the principle is, you know, is very appealing. I think you've got significant dollars that you've been able to spend. What does it cost to actually do one of these things for a particular cost?
Initially, the cost was exorbitant because we were doing it from scratch. Now that we have our templates in place, it probably costs in the order of $30,000 per unit to produce.
What did the first one cost?
It took 2 years of a federal grant, so probably in the order of $250,000.
I think, again, this is something that I wish I had when I was a student. I feel like I went to school at the wrong time. I think that one of the things that I was just wondering in terms of, obviously you led with most of your professors that developed this. So do you have a team that's working full time on this now, or is it still being done as kind of a side project or a part-time project?
No, I quit my tenure position at UGA in August, so I'm all in. And we're hiring our first C-level execs in January to go along with our raise. And we have a development team of 13 people at the moment.